So this is another type of model selection booster. Here we are using cross validation. So MSB2 or cross validation, this is a here we are using grid search for model selection and cross validation. So normally in a machine learning process, data is divided into training and testing. As we have been doing, the training set is then used to train the model and the testing set is used to evaluate the performance of the model. However, this approach may lead to variance problem. In simpler words, a variance problem refers to the scenario where our accuracy obtained on one test is very different to accuracy obtained in another test set using the same algorithm. So this is something which is important to keep in mind. So let us keep running also. We have let's clear this first. Yeah, clear this, and then we can rerun. So then we run it. You can see that nothing is going to happen here. So we will use k-fold cross validation. Here we are going to use k-fold cross validation because k is any number. So whatever number you want to assume, you can assume that. For performance evaluation where k is any number, the process of k-fold cross validation is straightforward. You divide the data into k folds. Out of the k folds, k minus 1 sets are used for training, while the remaining set is used for testing. So the whatever k number that you have given, k minus 1 are used for the training and remaining is used for the testing. The algorithm is trained and tested k times. Each time a new set is used for testing set, while remaining sets are used for training. Finally, the result of the k-fold cross validation is the average of the results obtained on each set. So that is what the algorithm that is used in this cross validation. Now we are importing the libraries as always. Then we are also importing the data set that we are going to work upon. The here in this case is wine quality, which we are putting it in a data frame. So that has been done. Now we are going for data analysis. So we are going to run this, get the details of the data with the df head. Shape also we can check, total number of rows and columns. Describe, you can get some kind of a statistics, that also we can get here. Then keys, we can also see that which are the keys like fixed acidity, volatile acidity, citric acid, residual sugar, etc. So all that can be seen here. Then data pre-processing, that can be done with the help of this. Execute the following script. They divide data into label and feature sets. So this is how we can divide the data into features and labels. So this is x is equal to df I log. This is the code that we have to write, dot values, and y is equal to df I log values. So we can run this, and this is how the division is taken place. Now since we are using cross validation, we don't need to divide our data into training and testing sets. We want all of the data in the training set so that we can apply cross validation on that. The simplest way to do this is to set the value of the test size parameter to 0 or 1. This will return all the data in the training set as follows. This is another way of doing this. So from sklearn model selection, import train test split, x train test, y train test split, xy test size is equal to 1, not 0.2 or 0.3, etc. Random state is 5. So 5 iterations will be taken. Then the data set is not scaled properly. For instance, the volatile acidity and citric acid column have values between 0 and 1, while most of the rest of the columns have higher values. Therefore, before training the algorithm, we will need to scale our data down. So this is also important to know and do it accordingly. Scaling the data, then we are going to again do this working, that is from sklearn pre-processing, import a standard scaler. This is required so that you can scale it, because we need to scale it, so we need something. So this is the library, sub-library of sklearn, which is available to do this. Xtrain feature scalar fit transform Xtrain, and Xtest feature scalar transform Xtest. So this can be again run like that. Training and cross validation. Then the first step in the training and cross validation phase is simple. You just have to import the algorithm class and the sklearn library as shown below. So you can see that we can import the library, that is from sklearn ensemble, import a random forest classifier. Classifier is equal to random forest classifier, n estimator is equal to 300, random state is equal to 0. So we can run this and nothing is going to happen as such, nothing is visible. Something is definitely going to happen, but then no result comes out. Now next, to implement cross validation, the cross val score method of the sklearn model selection library can be used. The cross val score returns the accuracy of all the folds. Values of 4 parameters are required to be used to be passed for the cross validation score class. The first parameter is estimator, which basically specifies the algorithm that you want to use for cross validation. The second and third parameter x and y contain the x train and y train data, that is features and labels. Finally, the number of folds is passed to the CV parameters as shown in the following code. So we can run this again and see that, of course, this is a remark, so nothing is going to happen. But from sklearn model selection, import cross validation, that is CV that we talked about, cross validation score, then all accuracies, cross validation score, estimator, classifier, x train, then y train, and CV is equal to 5. So when we run it, you will get, you will not get anything here, but yes, we are in the process of getting something now. So this has been done. After execution, let's simply print the accuracies. Now whatever accuracies that we have computed here, those will be printed. So after execution, let's simply print the accuracies returned for 5 folds by the cross validation score method by calling print of all accuracies. So we can run it. Of course, nothing is going to happen here, but we can then take the mean and standard deviation of the outcome of the accuracies. That also we can check, and we can print all that. So we can see that print all accuracies means that we are getting all these accuracies of that data that we have. Now print all accuracies mean, that can be done. It is the mean of this. Then the standard deviation of all the accuracies, that also can be done. You can get the standard deviation. Then grid search for parameter selection, that also of course nothing is going to happen in this. Then in a machine learning model has 2 types of parameters. The first type of parameters are the parameters that are learned through a machine learning model, while the second type of parameter are the type hyperparameter that we pass to the machine learning. So earlier, while predicting the quality of wine, we used the random forest algorithm. The number of estimators we used for the algorithm was 300. Similarly, in KNN algorithm, we have to specify the value of K, and for SVM algorithm, we have to specify the type of kernel. These estimators, if you remember, we have used all this in SVM and KNN, etc. The K value and kernel are all types of hyperparameters, right? So we can again run this. Then grid search with sklearn, that also is to be, this is just again a remark. Then let's implement the grid search algorithm with the help of an example. The script in this section should be run after the script that we created in the last section. To implement the grid search algorithm, we need to import grid search CV, and then class from the sklearn model selection library. So we can, again, this is again for our information, for our understanding. Let's create a dictionary and parameter and their corresponding values for our random forest algorithm. Details of all the parameters for the random forest algorithm are available in the sklearn docs. So if you want to go into details, you can go through in sklearn docs. Now we are going to calculate the grid parameter is equal to n estimators, 100, 300, 500, 800, 1000. Criterion is Gini entropy. Gini and entropy has been explained in the earlier tutorials. Bootstrap. So you can do this kind of a calculation which is run here. Here are create a grid parameter dictionary with these parameters, n estimators, criterion and bootstrap. The parameter value that we want to try out are passed in the list. For instance, in the value script, we want to find which value out of 100, 300, 500, 800 and 1000 provides the highest accuracy. So we also want to find which value results in the highest performance for the criterion parameter, Gini or entropy. The grid search algorithm basically tries all possible combination of parameter values and returns the combination with the highest accuracy. For instance, in the above case, the algorithm will check 20 combinations like 5 by 2 by 2. So we can run this also and nothing is going to happen actually. So once the parameter dictionary is created, the next step is to create an instance in the grid search CV class. You need to pass values for the estimator parameter, which basically is the algorithm that you want to execute. The parameter grid grid parameter takes the parameter dictionary that we just created as parameter. The scoring parameter takes the performance matrix. The CV parameter corresponds to number of folds, which is 5 in our case. And finally, the n jobs parameter refers of -1 for n jobs parameter means that use all available computing power. That can be handy if you were large amount of data, right? So this also is not going to do anything, but yes, now from sklearn model you can import grid search CV. This again is a sub library of sklearn, and grid search is equal to grid search CV estimator. This is a very good exercise when you will go for the data visualization, etc. So we'll show you that also when we are going to do that. So grid search is equal to grid search CV, estimator is equal to classifier, parameter grid parameter, scoring, accuracy, CV5 and n jobs. So when we run this, you will see, of course we are not going to get any output from this, but certainly internally some calculation has been done. So once the ID search grid search CV class is initialized, the last step is to call the fit method of the class and pass it to the training and test set as shown in the following code. So again we can run that also. So grid search fit xtrain and ytrain. So you can see that it has been fitted and the process is still on. Once the method completes execution, the next step is to check the parameter that return the highest accuracy. To do so, print the senior best parameters attributes to the grid search as shown below. So we can see that best parameter grid search parameters, print best parameters. So what are these that we can see? Process, of course, is quite a good calculation involved in this, so that is why it is taking a bit time. Let's wait for the process to complete and then we will see what is the result like. So writing the code is of course not much efforts, but definitely the processing takes a bit time. And sometimes we feel that we've written the code so quickly, but the processing is taking so much of time. But then you have to have the patience to see that the processing gets completed. You can imagine now that what is the role of these libraries that we have used. So that is why, although it is not required to understand the libraries in detail, but we must know that what are these libraries and what role they play. And that of course you will learn with practice, because more and more you practice, the more and more knowledge you will gain, and definitely you will become more and more proficient also. That is why it is recommended that one should not open so many of windows. I have opened lot many windows also, so that is also a problem, because every window is eating up some memory, and the memory availability is definitely not sufficient. That is why again it is taking more time. So now you can see that the result has come, and the grid research fit X-train Y-train. It gives complete details of the this cross validation. Grid search CV5, error score is NaN, that is not a number, estimator random accelerator, bootstrap, and all such details, which of course is very useful. And this is for our information again, because no result has come out of this, but definitely information has come out of this. So now this process also got completed. Of course, this is a remark, and here you can see that the best parameter for this is that bootstrap is equal to true, criterion is equal to entropy, and estimator is equal to 300. So this is the best parameter that we have got. Now the result shows that the highest accuracy is achieved when the n estimators are 1000. Now we found that 300, but here says that estimators are 1000. Bootstraps is true and criterion is guinea. So note, it should be a good idea to add more number of estimators and see if performance further increases. So that is the objective, and because in fact in this, you have the more number of tries that you give, your chances are that you will improve the results. So performance further increases since the highest allowed value of estimator are chosen. So you can again try with that. Now here again, to find the best accuracy achieved, execute the following code. So we can run this code also and see that does it make any difference or not. So we can see that we have got now 71%. So this is how you can keep on trying for improvement. So conclusion is that we have seen two very commonly used techniques for performance evaluation and model selection of an algorithm. K-fold cross-validation can be used to evaluate performance of a model by handling the two variance problems of the result set. Furthermore, to identify the best algorithm and best parameter, we can use the grid search algorithm. So that's how we can, after going through all that, we can understand all this. So this is the way we can do the model selection booster using the cross validation. Thank you.